Hello, algebra students. This video is mainly for first period and seventh period because they didn't get to see the lesson because they took a little bit longer on the quest than I thought they would, but that's okay. You guys are working hard. By the way, we may have some friends from second period, third period, or eighth period watching this video because they want to refresh their notes. So welcome to you as well. You all look so lovely today. All right. Hey, I want to tell you, quarter's almost over. You guys are doing a great job. I've never had a total of 3 D's and F's, and I've got a feeling that if some of you really decide to work, those aren't going to be D's and F's. So keep up the great work. All right, so let's get down with this. We're working with sets today, and first we need to define what is a set. What is a set, you ask? Dun, dun, dun! A set is a group of elements. The elements are the member of the set. In my second period, third period, and eighth period classes, one of the sets I talked about was that class period. So first period, the set of Mr. Lawrence's first period honors algebra class would be all the people in there. You know, Bobby and Alex and Caitlin and Morgan. I can't forget Hannah. I can't forget all our other friends, okay? That would be the set. It would include all the elements. By the way, it would include Mr. Lawrence, okay? So that's what a set is. It's just a group of elements. The elements are the actual items in the set. If we're doing with a set of animals, you know, maybe we're talking about mammals. So the set of mammals includes chinchillas and bears and cats and dogs and etc. Okay, so there's two ways to express sets. One way is roster notation, and roster notation is really easy. All it really is a roster of who's in the set. For example, if I wanted to make a set out of 10, 11, and 12, the roster notation would be like this. T, that's what I'm going to call the set. I could call it anything. Making a video. And I would include all the members that need to be in the set. I would just list them like a roster. So, there you go, roster notation. If I wanted the roster notation of seventh period, I would go ahead and list all the names of the students in seventh period. Okay, sorry about that. So somebody's at the door, but it sounds like there's pounding going on over in the guidance office. Okay, somebody must be hanging something. All right, so that's roster notation. Now, we also have something called set builder notation. Set builder notation looks kind of weird, only because you're not experienced with it. It's really easy. First, we're going to say T, and by the way, we're dealing with 10, 11, and 12 still. 10, 11, and 12, right? And so T is going to be equal to the set. T's just the name, by the way. I could have called it rutabaga if I wanted to. Don't do that, Rudvik. Okay. It's going to be the set of X such that. This bar here means such that. Okay. X is I look at 10, 11, 12, and I think N is a natural number. Right? X has to be, did I say N is a natural number? Excuse me, I meant to say X is a natural number, not N. X, all these are natural numbers. And some people might go, well, they are integers too. Yes, but I want to be as specific as possible. There are no other integers up here other than the positive integers. Well, the best way to describe the positive integers, the smallest subset, is the natural numbers, right? So, the set of X such that X is a natural number, where, the comma is read as where. Now, what do I notice? What are the boundaries on X? Well, it looks like X has to be greater than 9, right? Greater than 9. And X has to be less than 13. See, I don't have to worry about 12 and a half because I'm dealing with the natural numbers, or 10 and a half, or 11 and 3/4, or anything like that. Or 9 and 3/4 for you Harry Potter fans. That wouldn't be inside the set anyway. All right. Now, that's not the only way to write that part over there. You know, if I was Lexi Pullum, I might have said X is greater than or equal to 10, and X is less than or equal to 12. By the way, I would have to close the set notation there. All right. Now, you don't have to write both of those. You'd write one of those. Now, if you're lazy like me, I know Aidan Dauenhauer likes this way, and I think Maya Stoffers really likes it. To me, it's clear that X has to be between 10 and 12, or 9 and 13, depending on if I'm doing equals or not. So I might write it like this. I might go 9 is less than x, which is less than 13. Okay, or one other possibility, get some Poiple in there, I might do 10 is less than or equal to x, which is less than or equal to 12. And again, I don't have to worry about the fractions or decimals in between those natural numbers because I'm limited in the natural numbers. I wouldn't put all 4 of these in, I would only put one of them in because they all describe the set. So that's set builder notation. Hey, by the way, the MathXL appears to be fixed. So if you haven't done it yet, get it done this weekend. If you couldn't do 3-4 because of XL issues, those of you in second period, I gave you 0 points right now, and I typed a note like about XL issues. Get it done over the weekend, email me, and of course I'll give you the points. Okay, so we've got roster notation, and set builder notation, Okay, now I would like you to please solve for x, and let's pause the video, solve for x, and when you're done solving for x, we're going to try to write the answer in set builder notation. Hey, Rithvik's asking, why are we using set builder notation? Well, some sets are infinite, right? And if they're infinite, we can't possibly list all the numbers or all the elements. So therefore, we list it in set builder notation where we kind of describe the parameters of what the numbers are allowed to be. All right, so if you're still watching, I'm assuming you've already solved for x. I'm going to get that x is less than, I believe, -5. I think that's right. So it would be impossible to list all the numbers for x that make this true. I could draw a number line. That would show me all the numbers. But to list them out categorically would be impossible because they're infinite. So I'm going to go to set builder notation. And I'm going to go the set of x such that x is a real number, right? X has to be a real number because x could be, -10, -20. X could be -11.5. X could be negative of the square root of 100, right? So I'm including, negative of the square root of 101. I'm including all the integers below -5. I'm including all the rational numbers, all the irrational numbers. They all make it true. So I must be describing the real numbers. Okay, so the set of x such that x is a real number where, and then I just put x is less than -5. Okay, and yet this stuff is really easy. Really easy. Just had to give you the notes. All right, so let's move on here. Subsets. What is a subset, you ask? Dun, dun, dun. It's a set within a set. Yeah, that's what a subset is. So let's come down here and let's see if we can name all the subsets of the set CATS. Well, believe it or not, a set with no members like this is always a set, a subset of any set you're talking about. We call this the empty set, and we usually use a symbol like that. So the first subset I'm going to list is this. It's kind of like if there were 4 letters in a hat, C-A-T-N-S, and you had the chance to pick one out, and you chose not to pick one out. Okay, you had your turn, but you chose not to take it. That's the empty set. Your hand would be empty. You didn't pick anything out. The empty set is a subset of every set. Okay, now I'm going to list all the subsets that only have one member. Well, there's C, right? And then there's A. And then there's T. Put a little fish hook on there. And then, of course, there's S. I do this very systematically because I don't want to miss any. So first I wrote down the empty set, the set with no members, and then I put all the subsets that have one member. And I may actually type the rest of this here because it'll look better than me writing it. So hold on a second here. So now that I've done all the subsets with one member, I'm going to do the subset with 2 members, and I will go CA. and then I'll go C, T, and then I'll go C, S, right? And you see how I'm staying in order? I'm pairing C with A, C with T, C with S. Now I'm going to pair A with T. Then I'm going to pair A with S. And finally, I'm going to pair T with S. Okay? I don't believe there are any other subsets that have 2 elements in them. So now we'll do the ones with 3. So I'll go C, A, T. And then I'll go C, A, C, A, S. And then I will go, let's see, are there any other CAs? I don't think so. Now I'll go C, T, S. Okay. So that's all the ones with C. Now I'll move over to A, and I'll go A, T, S. And I believe that's it. I don't believe there are any other subsets with 3 members. And then finally, every subset is a set, every set is a subset of itself. Every set is a subset of itself. Every set is a subset of itself. So I actually listed that one there. Now let me move this out of the way. Let me count my subsets here. Let me get a highlighter and I'll count. Okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I actually knew there was going to be 16. I don't know if you know how I know, but I knew it. See if after doing Excel 3.5, you can figure out how I know. All right, so those are all the subsets. Okay, one more thing to learn, and then we can wrap the video up. And the next thing to learn is the universal set. And this is really easy. What's a universal set, you ask? Dun, dun, dun. It's the largest set you're dealing with. So on the last problem, we were talking about the set of CATS. That was the universal set. Okay? The universal set. Now, a complement, what's a complement, you ask? It doesn't mean, oh, I like your shoes. No, a complement means, dun, 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 all the elements that are not in the set. So let's say we have this set here. Whoa, what the hookah waka just happened? All right, a little crazy business going on. There we go. All right, so there's my set U. It's my universal set. And I'm going to name him U. There we go. And then inside of U, there's a heart-shaped set. Oh, it's a heart. How lovely. It's not even Valentine's Day, and Mr. Lawrence is making a heart. Okay, we're going to call that set A. All the members of this subset are in A, right? Whatever's in there. All the things that are in U but not in A are called the complement, A prime or the complement. A prime means A naught. All the members of U that are not in set A. That's what a complement is. All right, that's it for the video, ladies and gentlemen. Look, once more, I can't say how proud I am of you. It's crazy. I mean, I'd really like to see some of you eliminate the C's from your classes. I mean, first period, you only have 1 C, no D's, no F's. 7th period, you only have 2 C's, no D's, no F's. 3rd period, 2 C's, no D's, no F's. I mean, it's crazy. 2nd period, there's only 5 people below a B. And 8th period, there's only 6 C's. Just a little bit of effort, a little bit of getting help, a little bit of extra studying, we might do something that's never happened before. I don't know. I'd have to go out and play the lottery or something. I'm not a gambling man, but Jiminy Christmas, if every single student had a C or above or a B or above, I've never heard of such a thing. Who do you people think you are? No, I'm very proud of you. Keep up the great work, ladies and gentlemen. All right, Mr. Lawrence signing off. Have a good night, everybody.